G'day comrade subscribers. So what's the purpose of this design? Well, I've been working on this Soviet Ukrainian computer, so it's called the UMPKR32. I think it stands for Universal Microprocessor Kit for radio. And I think I've almost got it working. It's based on the DIY Radio 86RK machine that came out in the I think mid-late 80s, well 1985, 1986. And it's designed around the Soviet 8080 processor. So I've almost got it working. I've been, most of the DRAM I've replaced. I probably have to replace the remaining bits. And I've got a new video. It was RF modulator output, so I've designed a little baseband video output. But anyway, even if I get the machine working, there's still the issue with the keyboard. It's a membrane type keyboard, so it's probably not working. So it uses a material called foil lavsan. So lavsan is a Soviet era trade name for it's for PET. It's a polyester film for a PET film similar to Mylar that we have in the West. So and it has a thin layer of aluminium on it usually, hence why it's called foiled lavsan, and that's used as the conductive part for the membrane. So after a few decades, it's probably starting to break down. So let's see if we can design a modern replacement using key switches that hopefully can fit within this this size here. So this is a design I did earlier for the Husky Hunters. This is my first kind of keyboard design from scratch. As you can see, it's got 17 pins, but nothing else really. It's just key switches. This one I had to design from the membrane. I had to reverse engineer the membrane because there wasn't a schematic I could find handy. Because yeah, the problem with that machine was that the membrane had started to break down because of battery leakage. Which is why I've made this replacement. So it's quite nice feel to it. Anyway, so for the UMPKR, we're quite fortunate that we've got two schematics that we can refer to. So this is the original schematic for this particular machine, and we've also got a modern schematic that Sergey has done for the his modern 86RK re-implementation. So I'm going to go off the original design primarily, but refer to Sergey's just in case there's any kind of anything that's not really clear. So actually looking at it, it looks like you've got diodes on the columns and then pull-ups on the rows, but it's actually like that. So we've got diodes on the rows and pull-ups on the columns as per Sergey's thing. So this so this is like what's called a matrix keyboard with diodes and pull-ups. So the resistors, so let's look at Sergey's. It's a bit clearer, I guess. So Sergey's with the pull-ups on the columns, it's going to pull the columns up to 5 volts. So the columns will be at a known voltage, and we've got diodes on the rows, so the rows will be pulled low in turn. So the diodes are there basically to ensure that current only flows in one direction, well, the intended direction, to avoid issues like ghosting. So ghosting is when you press, I think it's when you press, say, 3 keys and a 4th key, a phantom key is registered that shouldn't be registered. And there's also masking, where you press a key and it doesn't get registered because the current flows in a way it shouldn't. So hence the diodes, to ensure that we've only got one way current flow. The main issue with it, well, there's two main issues with this designing replacement for this keyboard. The first is going to be probably, I don't know, let's maybe, I'm just trying to have a look at the, we might be okay with the key switches. They do seem to, we might be okay fitting the key switches in, but the other main issue is the use of the connector. So this is a Soviet era connector, can't get in the West. It's an SNP58 PCBWAY-32. It looks like a DIN, what is it, 41612, but it's 2.5 mil, not 2.54 mil, and that does make a difference. And in that, it won't, the DIN connector is a little bit too wide, so it won't fit. It won't fit the receptacle. So what I'm going to have to do is probably design a footprint, so reuse this, desolder it and reuse it, and then design a footprint so that it'll go on my new PCB. Otherwise, and so we've got our pull-up resistors here, and we've got our diodes here on the rows. I'll just use Western Parts for that. Same with the capacitors and the LEDs. Probably reuse the speaker. I just need to, have make sure I've got a connection, and just have a. Well, okay. So I was going to say a circular hole, but it's actually a bit of a design. So I'm going to have to design the cutout in the PCB for that. But that's far in the future at the moment. Yeah, so I'm not sure how far I'm going to get into this first part of the video. So first, what we're going to do is get this schematic into KiCad, and then do the footprints. So, like I said, I'm going to have to design a footprint for this SNP58 connector. And then see if we can fit everything into whatever size this is. Let's see how we go. Okay, let's get started. So we've got the KiCad project set up. Open up the schematic, the schema. So let's start plonking stuff on. So normally I'd just stick the interface on the header, the connector first, but I think that's going to require a bit of work because it's a 32 pin connector, but there's only even pins. So I think it might actually be a 64, physically the size of a 64-way connector, but all the odd pins are missing, so we've only got even pins. So we start off at A2, B2, then we've got A4, B4. So I think that might require a little bit of work. Definitely for the footprint, I'm going to have to modify that from 2.54, a DIN 4114612, I think it is, to 2.5 mil pitch for the Soviet. But also I think even the schematic, I might need to fiddle around with that. So anyway, what do we got? We've got some key switches. So what I've done is I don't need to worry about that. That's footprints. So I think, what is it? Switch. What do I normally do? I do key switch. Key switch, no. Key switch. Ooh, push button with LCD screen. No, that's not the one. I might have to look up what I did for my other keyboard, for my Husky Hunter. Is it on here? H, isn't it? Husky. There we go. Open that one. So what have I done here? It's a bit of a rainy day today. What is that? Let's have a look at side footprints. Okay, so button switch. Okay, button switch keyboard. That's what it's called, button switch keyboard. Right. Okay, that's probably because I've upgraded KiCad. Button switch keyboard. Open recent. Okay, let's go back to there. Okay, let's try this again. Button switch keyboard. Maybe. Oh, that's cool. That's cool because buttons. Okay. So because this is just the logical. This is just the logical. Yeah. That's just for the schematic. So it doesn't really matter what we put on there because ultimately it's the footprint that's going to decide what it's actually going to be. So I think that's probably the easiest one to do. Is just switch push 45 angle degree. Okay. What's this one? Alright, so let's do that one. Alright, so what have we got? We've got a matrix. Let's do it that way. I'm going to keep this one here. Use that one there. Alright. There we go. Yep. So we're doing rows and then columns. So first row, second row, third row, fourth row, fifth row, sixth row, seventh and eighth. Okay, and then we can just copy those. 1, 2, 3, 4. Yeah, those ones have got some extras. No. 1, 2, 3, 4, 5, 6, 7. All right. All right. So there's 8. So I need to do. Probably I could wire them up first, but let's just do this. So we need 8 in total. What have I done? 1, 2, 3, 4, 5, 6, 7, 8. So that's roughly what it's going to look like. So we've got the rows here. So now we need to add our passives. We need to add diodes, so we'll have diodes along the rows here. Of course there's going to be loads of diodes, so it doesn't really matter. We'll just put a D for a diode. A diode on each row. We'll have to do some customization because some rows don't have, for example, this one here I think is missing. Okay. And now for the columns, that's where we're going to have the pull-up resistors. So we won't worry about that at the moment. So basically, I think we go down like this, and then across like that. Something like that. Guess what we should do? You know what I should have done is, before I copied everything, what I should have done is lined everything up. Can I do this here? View tools. I don't know. Place. Doesn't look like it. Alright, I'll just do it by eye. Well, it's probably something I can. Actually, that's what I just need to do. Is just do that down to there. That's the way to do it. And that's all like that. Of course the vertical separation as well. Don't want to put them too close. That's great. Alright, that'll do then. That'll do, pug. So let's get rid of that. Oh, okay, that's alright then. I'll draw that up there. I'll just get rid of that. There we go. So actually that's what I should have done in the first place. Should have done it like that and then copied it. Now we need a bit of space. So that's 4, and then what, we need 8 in total. So let's just copy that, and then we've got our 8. Something roughly like that. So I've got the columns connected. Now we need the rows. So that should go something like this. And then repeat for everything else. But like I said, a couple of the columns or a couple of the rows, we just need to remove a switch or two according to the schematic, like that. And then we've got the diode connected there, and then that goes off to the connector. So we'll probably have, so for example, this one here, it says connection 1, which is then B12, which actually connects to PA0 on the 8255. So I'll probably call that PA0. So I'll probably do it like this. That's where it's ultimately going. Like that. And then obviously just repeat for all the rest. Now the columns are going to connect also to the 8285 via, but we're going to have pull-ups as well. So I'm just going to finish this off and then we'll come back to it. Okay, I think we're just about done, except for the connector. So we'll go through everything. So on here I've got the connector pins and then what they connect through to. So we've got the reset, for example, the reset button here. Interesting that apparently the speaker is connected to 12 volts and whatever pin on the looks like it's there's a speaker enable, yeah. Anyway, whatever. So that's what that there is for, and the labels here are the connector pin. So hopefully that all makes sense. We'll have a look over here at the keyboard matrix. So we've got the rows here. So B12, for example, is B12 is connected to port A0, and we've got A1, blah 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 blah. So for the rows, we've got the diodes, and then on the columns, we've got everything connected to pull-up resistors to 5 volts, A28 and B28, the 5 volts, and A30, B30 is the ground or common option. So and that's why I've got them here. They're connected together, so I've just done that. Anyway, whatever. Now, yeah. So on this circuit, we're using 2K pull-ups. Now, I'd probably, not that I'm an expert, but you know, use something like 10K or something. Sergey uses 4.7K on his 86RK, but they're using 2K on this one, so 2K is good enough for me. What else? We've got the 2 LEDs So we've got the power LED, which is basically between 5 volts and ground. They did have the resistor on the ground side, so I've just moved it to the 5 volt side. And then we've got the Russian and Latin font selector also here. What else? So we've got, like I said, we've got the speaker connected between a control pin and 12 volts apparently, so okay, whatever. We've got a whole bunch of capacitors in parallel between ground and 5 volts. So we've got an electrolytic, and then we've got these 4 68 nanofarads in parallel. So I'll just reproduce what they've got. And then we've got these special keys that aren't part of the matrix. So A30 is what is it? Okay, ground. And then we've got going to specific control pins. So we've got control, we've got shift, and the reset is just between A2 and B2. So that just does the reset of the machine, which I think connects to the reset in pin on the 8224 on the clock generator. I think that's where that goes. So pretty much done. It's pretty simple when you look at it like this. It's not. Let's move those in a little bit. Nothing too difficult. Now for the connector. So let's see what we can find. So normally I would just use like a generic connector. So we've got 32 pins. So I don't know if you can do a 2x16. Doesn't really matter, I guess. I don't know if there's if you can do 02x16 or 02x. Well, actually, this is the DIN41612. That's exactly what we need actually, because that's what the SNP58 connector is a copy of, really. So what options we got? We've got AB even pins. Ah, perfect. A2, B2, A4, B4, A6, B6. That's exactly what we need. That's what, yeah, perfect. All right, let's whack that in. And we'll just stick it there for now. Okay, let's just move these around a bit. Just okay. Whoop. Let's move these. I could probably move them closer together as well. Like so, and I can move the connector down like that, and then yeah. So this will be XS1. I'm trying to use the same part numbering as well. So instead of D1, D2, D3 for the diodes, I've got VD1, VD2 because that's what they've used. Yeah. Anyway, so this is XS1. That's what they call their interfaces. Alright, so now it's just a matter of, well, A4 and B4 are not, so let's just do the not connected ones. So A4, B4 are not connected to anything, as far as I can tell. A14, B26, they're all not connected to anything. And everything else is just a matter of putting on the label, I guess. A2, like so. A6. So I'll do all these labels, and then we'll, I guess, yeah, do the footprints. Although, so this one here, I'm going to have to edit to change the pitch probably, but we'll see what's available. There we go. So I've got the connector on there. I've renamed it SNP58-32. So have a look at the. So that's the schematic. Pretty much, it's kind of on the side compared to what I've done. So we've got the rows. Rows are actually rows, not columns. So we've got those four capacitors in parallel plus the other one. there between, so because we've got, so 21 is 5 volts, so 21 there is 5 volts. So we've got C5 connected between 5 volts and ground, so 17 is ground, obshare, common. And then as I say, I'm looking at the, so this is the BOM, you can see here, so 2 kilo ohm, so we've got 25 lots of 2 kilo ohm, then R4 and R5 are 330 ohm, so they are the limiting resistors for the LEDs. And then we've got another 5 2 kilo ohm, which are all the pull-ups. So I've just got a 12 pin, but 11 way resistor array. Maybe a bit overkill, but anyway, better than 11 separate resistors. So that's the connector all done. As you can see down here, it's an SNP58-32/95 times 9P-20-20. I think what were these? These were the LEDs. This is the type of diode, so it's a KD521A diodes. So I'm just using plain one, small signal 1N4148. That'll do. Anything else? We've got the capacitors here, so we've got a 10 microfarad capacitor, 16 volt. And then we've got these 68 nanofarads, nice square ones, sharp edges. So we could probably do a little bit of optimize. We can run. Actually, let's just run the electrical rules checker a couple of times. Let's run it again. So I was getting all those errors before because I had say B14 just there, it wasn't connected. Well, in this case, B14 is a bad example because it's connected up there. But I had, for example, B2, and it was only connected there. So that was what those errors were about. So okay, A20, A22, not connected anywhere else. A28, B28 connected. So A28 we're using the net list. So what I could do there, so that's like the 5 volt and the ground. These ones here. That's the 5 volt and ground pins that are basically connected together. So what I can do is it said A28 will be used, so let's get rid of B28 and then we'll just put A28 label there as well. Yep. And what else was it? No, I've lost it. There. No. Let's run it again. Electrical rules checker. Okay, so warning A28, B28 attached to the same. A28 will be used in the net list, and same with A30 and B30. So A30 will be used. So let's get rid of B30 and just call it A30. So A30 and A30 will be connected together, which of course means I don't need those anymore. Get rid of the little arrows. What else was it complaining about? A18 is not connected anywhere else in the schematic. So what was A18? A18 is PB7. So there's A18. Let's actually have a look on the original schematic. A18. What was it? PB7. So I think it was that one. I think that's A18 there. So that is 26. Signal 26. Which is this one here. 26. Ah, it's the pull-ups. Right, so I've got the pull-ups. Ah, okay, this is what I've forgotten to do, I think. Silly Billy. So I've got all the columns. Okay. So I've got all the columns pulled up to 5 volts, but they're not being sensed anywhere. So I need to connect. Right. So for example, this bottom row here goes to 26, and so 26 down here. And then 26 over here is connected to A18, which is PB7. A18, PB7, A18, PB7. So A18, yep. So I need to connect this column. So how does it go? Okay, oh yes, so we've got the pull up there, and then we've also got it connected to, so that goes to, oh, it's the columns, that's right, it's the column. So it should be this column here. So I could just, whoops, I could just stick it down here, couldn't I? Well, where's a good place to put it? I'll just stick it up. Stick it up here. So I should have, what was it, A18? So I should have it, I'm going to have to tidy this up a bit. Yeah, I should have it like that. So if I run the electrical rules checker again, yeah, A18 is now gone. So I think that's right, isn't it? It's connected to the pull-up, and it's also connected to the 8255. So I just need to fix those there, and then I'll be able to do, then it should clear. Yeah, all right, let me do that. I think that's everything now. So I've gone and renamed the labels. I've just put the actual signal names as well, just to give a bit more sanity checking when I'm doing it. It makes a bit more sense. It's like, okay, yeah, that's 5 volts, that's ground. So yes, I've added the B ports on the columns now. So we've got PB0 through to PB7. So that should be just about it now. We can run electrical rules checker quickly. Hey, all good. Relatively happy. All right, but we just haven't assigned footprints yet, so should be able to assign footprints pretty easily for most of them. So we're going to use cherry. Well, let's have a look at the key switches. So what I've done is, if I just switch back to the plugin and content manager, what I've loaded, what library I've added in this key switch KiCad library footprint. So I've installed that. So it's got a whole bunch of different key switch footprints already in there. So that should hopefully make that a little easier. So it's saved. Let's go to assign footprints. Right. Okay, that one's already assigned. That's too easy. Speaker, yeah. So the speaker cutout is going to be custom. So, all right, let's do capacitors. Capacitor. So it's a through hole, so capacitor through hole. Before I think I've got pitch 5mm. It's radial. Pitch 5mm. I think I've got. I think it's got a. Was it 5mm or is it 2.5mm? It's quite a small one. That's not 5mm. That's 2.5mm. I think. So I think that one will do. Radial. Oh, hang on. Even smaller. It could be that one. I reckon it could be that one. It's quite a small one. Let's go. Right, let's just do that one. Double click on it. Let's try that again. Oh, I've got to find it again. What did I say? Pitch, I think it was 2.5, and it was radial. Need to select it first, don't I? That one there. For these are capacitor. Through hole again. And disk, yeah, C disk. and I'll just use 5mm. I think either 5mm or the 2.5mm pitch, I'm not sure. Let's just do the 5mm. So we'll just select those. Okay. Resistors I can never remember. Now, okay, well, let's just do the key switches. So let's have a look. So what was it called? What was the footprint? What were the footprints called? It's under switch. Gonna do a search for cherry. No, probably because I'm still selected. Okay, connector. What was it under again? I did find them. Switch, key switch. Oh, here we go. PCM. What's PCM? Pulse color modulation. Okay. Cherry MX. Just okay. Just cheapo standard ones. So 1U for most of them. Space, I guess I could make a little bit wider. I don't make it too wide. I wonder what the difference between that and that is. So let's, apart from that one, let's just do those. And then for the space bar, let's do, I don't know, that one. Alright, so that's the key switches done. LEDs. We need to add mounting holes as well, don't we? But that's once we got 1, 2. We do have a few mounting holes actually. 1, 2, 3, 4, 5, 6, 7, 8. 8 mounting holes. All right, remind me to add 8 mounting holes. These are LEDs. There we go, LED through hole, just standard. So it'll be 5mm horizontal, 5mm clear, flat top, just 5mm. I think that's it. That'll do for a start. And then diodes. Okay, this is the one I'm going to have to. So do we have DIN41? Do a search, connector DIN. So there are footprints already. So, but I'm going to have to modify it. Well, let's just throw one in anyway. So it's female. All right, I'll have to do a bit of research on that. Let's just do the diodes now. Diode, through hole. Yeah. I don't know. I haven't done diodes before. Okay, what package type? Yeah, they're just normal diodes, man. Alright, I'm going to do a little bit of research. Find out exactly what these packages are called. I'll be back. Okay, always start okay, sorry. Just about done, I think. Speaker. Yeah, so let's have a look what I've done. So, sign footprints. So I found that I've also got these button switch keyboard for the key switches. So I think I've used those before. It looks a lot simpler. So I've just switched to using those. So pretty much everything's a 1U, and then I've done 2U for the spacebar, just a small little spacebar. But we'll see how we go. LEDs. So diodes. Apparently those little 1N4148s are DO35 package. So I've selected those. Should be enough space for them. What else have I got? So resistors, that should be enough. Horizontal. Capacitors. Now I've added the 8 mounting holes up here. The crosses just mean that they're excluded from the simulation, so it doesn't, I'm not running a simulation anyway. So if you do get rid of that, if that annoys you, then yeah. So it doesn't matter to me in this case. And they've got, they're all grounded, they're all connected to the ground plane, so I've connected them up to ground like that. And I've selected the mounting hole with a pad, so basically just M3 with a pad. They're all these ISO this, ISO that, DIN that, so I just thought, oh okay, I'll just go for this one, nice and simple. So that's just about it, apart from this DIN41612 light connector and the speaker. Speaker, I could just have a circle for that. It's a circle and 2 screw holes really, and then a 2-pin header. So let's just okay, let's have a look at the DIN connectors again. So it's connector, I've got it, where was it? Connector DIN up here. Okay, so it's DIN41612. It's female and it's vertical and it's through hole. Okay, so we've got these B, C, 2, E, I'm not really sure. So it's, I counted it, so it's actually 2 rows of 32 pins each, so 64 pins in total. So I'm guessing it's a 2x32 is what I need. 2x32. So I've got a B or a C option. What's the difference? What's the difference? Eurocard type B or type C? What's a type C look like? Well, I don't want right angle. I know that's just for reference, but that doesn't really help. Let's have a look at the data sheet. I just going to have to look up. Okay, style C, straight or right angle. Type B. What's the difference? Rows loaded A and C, A, B and C. Okay, straight receptacle. Whereas a B, oh okay, so I want a B then I guess. A only A and B. Yep, so I want A and B. What's 2? I don't, well this is just, I need to modify this anyway. So I think that will do. And for the speaker, let's just do a connector, just a pin header for that for now. And I can always, actually that's what I might need to do actually, a pin header for the actual connection, and then on the PCB I just draw the hole, maybe. That's what I need to do. So that's a 1x2 vertical. Well, it's just the holes anyway, but that'll do, I think. Yeah, okay. Ready to go. So, let's see. Update PCB from Schematic. Okay. There we go. Okay. Here's everything. Oh, that's my space bar. There's my mounting holes. Okay. All right. Oh, this is going to be fun. I'm going to have to put everything in the right space. Okay. So this is the DIN connector. Let's just move that out. It does kind of look correct. But as you can see here, I just got to make sure, because obviously on R1 we don't have the odd we've just got the even pins, which I think might be right if I have a look at it. Yeah, like, okay, yeah, so the odd pins are actually missing. So this might be okay, but I need to edit it though, because if we have a look at the if we we want to open footprint editor, right? So because our problem is, where's our rule? Is that's 2.54. So we need to actually change that. So this actually needs to be slightly closer. That's effectively what I need to do. So everything needs to kind of slightly move up 0.04 of a millimeter, and then it'll be good. But we won't worry about this now. The main thing is, I think this is okay. Yeah, I think this will be okay, because you can see these ones aren't connected at all, so we just ignore those. In fact, what I could do is actually just delete them from the footprint editor, because they're not filled in. Right, so now what I looks quite. So this is an A4. Maybe I need to change. Let's change the page to an A5 so we don't have that in the way. Oh, sorry, A3. Now what I need to do basically is get all my key switches. Well, what I need to do actually is draw up the board, draw the physical dimensions of the board, and see if everything will fit in. These, I've tried to save some space by using a resistor array. These will go around the edges, and got diodes, and then like I say, a speaker. I could even replace the speaker and put a little piezo on there maybe. Alright, let me sort all this out and measure up the board. Oh yeah, they're the diodes. Alright, so I need to measure up the board and then obviously get everything into the right order. That's going to take ages. What I probably could have done, I switch back to, is on here to make it easier for myself. I probably could have put in the switch number or in the naming here, row 1, column 1, row 2, row 1, column 2. That's alright. What I can do is actually just print this out really, can't I? Or I can look at the physical keyboard next to me. But I can see here switch 1, switch 9, switch 17, they all, oh no, this is the matrix, silly. Yeah, I need to look at the physical keyboard. Okay. I know what I'm doing. I've done this all the time. I'm an expert. Hardy ha ha. Switch to PCBWAY. Alright. I'll get started and we'll see how we go. Okay, I found the, that's the first top left, according to the keyboard. That's the top left key, but I've measured the board, the PCB. So it's 30 by 32 by 20. 32 by 20. And we have a goldfish. So it's 32 centimeters wide and 20 centimeters tall. 320 mils, 200 mils. So I need to do, let's see, edge cuts, and I need to draw my box, draw my rectangle. I might just draw it over here. Okay, no, I just need to draw it over here. Okay, what's that there? Edge cuts, that was me drawing that, wasn't it? Okay. And here, I just wanted to do, okay, start point, end point, oh, okay. I'll just do that. On the XO, 320 mils by 200 millimeters, there, okay. So that's the size. That's the size I've got to work with. I might just get it out of the way for now. Put it over there. It's just, it doesn't really matter, the drawing sheet. Let's just make the drawing sheet even larger. It just annoys me if it gets in the way. A0. A2 should be big enough, shouldn't it? There we go. Alright. So that's, we've got to fit everything on this. And right, now I was going to fillet the corners, but then they become separate little things. If I want to move it around, I'm going to, anyway, whatever. So actually what I should have along the bottom is the space bar, shouldn't I? There's the space bar. Space bar, I think, was up the top. So it's switch 59 is the space bar. 67. Oh, it was the 2U one. Here it is. Yeah, made it a little wider. What? No, don't do that. Ah, don't do that. What do you? Ah, don't do that. All right. So that's on its own. Just trying to think of if there's anything else I can put along here. No, not really. All right. Now on the next row we start with the SS, which I think is Control, or is it Shift? Here we go. SS switch 66 Shift switch 66. So we start with switch 66. Some here. I know there's probably some more efficient way of doing this. Maybe if I'd numbered them in the order that they are on the keyboard. So top left is switch 1, then they would have been in some sort of order. Let's just get that there. Okay, the next one is YA and Q. So yeah, didn't mention this at the start. So it's a JCU KEN layout. So there we go. So it's switch 11. So I'll start doing all this slow stuff. Switch 10, switch 11's up here. So we've got the not the footprint, the what's it called? The courtyard. Is that the courtyard? So I think I can bump them up, because that's the physical key switch, isn't it? Maybe I should have a little bit of a space, but the problem is then you want to make sure you get the same amount of space each time. Can I do this? So that's 0.3 of a mil, 0.4 center to center, 0.3 of a mil, 0.3 mil. All right, so I'll go through and try and get all this to fit in, and we'll see when we see. I think I'm just about done for today, at least, anyway. So the keyboard's roughly, I need to adjust the positions a bit. So for example, the keys are roughly in the same position as they are on the keyboard, but I've made some changes. For example, like I've made the cursor kind of cluster here, makes a little bit more sense. The delete key, I think, where was the delete key? Which one's delete? Yeah, so the delete key was down here. We got return there, so we got delete, return. So I've moved, so delete's up the top here. Same with the function keys. So the function keys are up the top here. So I've made some adjustments, and I just need to adjust the spacing a bit. So I've just done it by eye at the moment. But what I can do, for example, is if I'm happy with the way all those are, I can select them all, and I do align distribute, And then we can distribute horizontally with even gaps. So they all have the same kind of gap sort of thing. So I don't know whether I want like a rectangular keyboard so everything's in line, or whether I want the keys offset. So the keys at the moment on the existing board are offset. I just don't know how much space I've got. So for example, like the Russian Latin key, so that was over here, but I've moved it separate because I was running out of space actually. I probably could put it back over there because there is space now. So I probably could put it there. And then once I'm happy with, say, the spacing on a particular row, then what you can do is you can obviously group them all so that you don't muck them up in future. So yeah, so this is roughly the layout. Everything kind of fits. The mounting holes, I've got the mounting holes where they are at the moment. They should be pretty accurate. What I'll do is I'll do a printout anyway and make sure the holes are in the right places. So speaker, I still need to do a cutout for the speaker, but I need to finalize the layout of the keys first. So like I said, I've got escape, AR2 up here, and the function keys, move them because they were around the cursor cluster. Resets up here by itself. I've got the LED, so some refinements, and obviously I need to still adjust this footprint. This footprint's not correct, so I need to modify that, but I'll do that I think in the next video. I don't want to do too much in the one video. Yeah, so I guess one other simple thing I can do is we do the ground plane. So the ground plane will be on the back. So pretty much, which one was it? I should be able to tell easily. Here we go, A30 ground. That's the one. There, and there. So that's, I don't need that until I've done the routing anyway. Yeah, so that's it for today, I think. Made pretty good progress. Got the schematic done. Just about got the keyboard done, and it does fit. It does fit. So I'm pretty happy with that. I've just got to make sure also, because the case is it's got a little bit of a lip, so I don't want to be too close to the lip there. But yeah, I think it's looking good. So and yeah, thanks to PCBWAY. So I'll be asking them if they can get a set of these done up for me and sent out so we can do some videos on them. So yeah, to be continued, probably tomorrow. Hey, good morning. Yeah, I decided to continue. So I've been fiddling more with the keycaps, and apparently you should be able to. So this square here, this outline's 19.05 millimeters, which apparently is 1U. So you should be able to have them basically lined up like that. So what I've done is I've set the grid to 19.05 millimeters, 3/4 of an inch apparently, and that way I can just snap them all together quite easily. So that's what I've been doing. So I'm on the third row here, but probably you can, I don't know if you can see. I'll try and snap it. You can see at the moment it's snapping to this circle there. So if I just try and bring this down here, it's not going to snap properly. I need it to snap to the middle, so what I need to do is hold it down so it's moving, and then on the Mac hold Command so it's free to move. And then where was the circle? There's the circle there. There's a grid point there. So if I move it up here until the grid point's roughly, let's put this one here in the center there, so it's slightly off. That's alright. Now should snap to it now. No, snap, no, down a bit. There we go, now it's snapped to it. So now I should be able to, there, perfect. So I'm just going through and redoing all of these, so you can see you've got a grid point there. So again, roughly go to the center there, perfect. Yeah, and I've switched to, let me just save that, switch to schematic, assign footprint. So I've switched to those, what was it, PCM. So these ones that I downloaded, the library. So PCM key switch, switch keyboard cherry. So 1U. I've done 2.25U for the spacebar and for the carriage return. Thinking about it. Still fiddling around with it. So you can see the spacebar here and the carriage return. Yeah, and so I think pretty much I should just about be done, apart from drawing the cutout for the speaker. So I might actually do that as part of this video, do it all in one part. So yeah, I'll finish off the keyboard again. I think this is just about it, yeah. So I think I'm going to settle on this for the keyboard design. I've got the cursor cluster down here in the corner. I've got slightly bigger carriage return key, and I've got a little space bar there. I could make the space bar bigger, but then I'd have to put stabilizers in and stuff, which I think I do have, but I'm quite happy just a little space bar. So we've got the power LED, the Russian Latin font key LED. I've got the reset up here. I did have the reset above the delete, but I thought, well, better have the reset out of the way. And then we've got the capacitors up here. We've got the diodes here. The pull-up resistors there. So all we need to do now is basically do the cutout for the speaker. So we could I always forget to do that. So could just, I need to do that on, first of all, just don't do it on any random layer. You need to do it on the edge cuts, don't you? Alright. So I could just do a circle, whatever size. I need to measure it. But as you see from the picture, it is a little bit of an odd size. So if I wanted to, I probably could maybe, I don't know if I can do it like this. I have to rotate something like that. This is just roughly, no, I meant to move, there we go, move, and then I need to rotate, so probably need to go to properties, so I could probably, where is it, positioning tools, relative to, I think it's not something, oh, okay, rotate, yeah, that's what I want to do. Okay, that's just going to do 90 degrees at a time, is it? So I could do something, draw the shape, I guess, something very simple. I need to measure, I'm just fiddling around here at the moment. And if we do that, if we select those two, select that and select that, have I selected them? I'm going to fiddle around with it because I've never done this sort of thing before, but I can either just do the circle cutout, and then obviously I need probably a pair of mounting holes either side, just M3 mounting holes either side, and that's probably good enough. But if I want to match what it was, need a little bit extra work. I'll see. This is essentially the shape. So it's 36 diameter, 36 millimeters diameter, and then we've got this little 10 by 15 cutout. So I want to rotate that to some. It doesn't need to be rotated, but I guess it would help. So I think I can. What was I doing? We're going here, positioning, move exactly. So I can rotate So if I want to rotate, say 45 degrees, there we go, okay. So it's kind of like that. Actually, no, it isn't, sorry, it's half the circle, and then it's this. It's almost like that actually, because what was this? So 18 radius, and this was 15. So that's where the center is. So it's almost, yeah, it's kind of, yeah, it's almost like that. But then I need to cut the circle in half, so I need to draw a line, don't I? Basically need to draw a line. That's at 45, so what's that, 135 degrees. Like that. And then again from here to here, so they'll be at 45 degrees. Like so. So it's kind of like that. And then what I want to do, obviously that's not touching there, is it? What I want to do is then, is it chamfer or is it filler? I can't remember, it's so long since I did bloody CAD. It's been a while. So I could probably do this more accurately, you know, move relative and things like that. So I'm just fiddling around at the moment. So if I select that, so I've got the circle selected. I think I've got that line selected. Shape modification. Heel shapes? What does that do? Alright. I don't know what that did. Oh, I could probably just draw it, but what I want, the other thing I could do is draw the circle, then draw a line through the center, and then cut the circle in half, if possible. Or I could just have the circle. Just have the circle. Alright, I'm going to fiddle with this a bit more, see if I can figure it out. Use an arc. So, let's draw it. I think that's the kind of like the center there, isn't it? Yeah, okay, so we want to draw what's that? So that's 270 degrees, is it? Alright. Oh, okay, so that's, where's 0 degrees? Oh, that's 0 degrees there. Oh no, that's 360. Oh, okay, no, 360. So that's, okay, that's 0. Let's start at 45. It needs to be 18mm diameter. Do 18 mils that way. Anyway, let's do roughly and I can adjust it perhaps. It needs to be 45. Okay, then draw it around to here, so what, 135. Okay, right, so we've got that, and then this kind of goes in the, alright, how do I position this? That goes in the middle. That's the cutout. And then I need to draw a line here. Oh, I can do it like that, can I? And then here to here. And then can I just move this? Oh, no, it's not going to move the line. Ah, okay, it's not going to move the lines as well. Ah, okay, so what I should have done was, okay, maybe just draw a line across. Like so. Okay. And then this. Ah, I didn't mean to adjust the size. That kind of goes in there. Where was the midpoint? $12.67. I'm just off the midpoint. So that's essentially what I need. That's the shape I need. I just need some way of fine. Can I move? So I need to kind of move this so it's. Oh, okay. Didn't actually draw. Oh, yeah, that's right. I did two separate lines, didn't I? But something like that. Something like this. Unless I make. Can I make the. Alright, that's the origin of the grid now. I just wish it would show up so I can eyeball it. Alright. But you know what I mean. So we'll figure it out. We'll figure it out. I'll figure it out somehow. Probably should have just drawn it. Yeah. Probably should have just drawn it normally. So what's the grid? Let's do, say, 1 mil. Okay. Because we know it's got to be, radius is 18. Perfect. And then, perfect. Alright. And then that way we know that that's the center point there. So let's move this across. I think that was the center point there, wasn't it? Yep, that's the center point there. So we just rotate this. Was it properties? Or was it positioning tools? Let's just redraw it. Move exactly, there we go. So if we just do 0. Ah, what? Positioning tools, move exactly. Huh? What? Oh, okay, I need to rotate it, don't I? I'm rotating it 0 degrees, so I need to rotate it another 45 degrees. Okay, wrong way. Let's rotate it negative 45 degrees. Alright, negative 45 there, okay. And that was the center point there. So that means that's it there. And then we draw a line to there. Yeah, and then I draw a line to there. Perfecto. And that's basically the shape. So now if we group it all together, do I group everything? Group it all. Group items. Is it going to let me do positioning tools? Move exactly. 45. There we go. So I'm hoping, I think that should be it. So let's have a quick look at the 3D view. Is there a hole there? I should have saved it. No, there's no hole there. Alright, I need to figure out how to do holes. I haven't done holes yet. Because it was edge cuts. Oh, of course, edge cuts being edge cuts, isn't it? On the edge. Alright, I need to figure out how to do holes in the middle of the PCB. I found the problem. So just don't do the square or the oblong. So just draw it. So I've rotated it back and it's nice and simple because I'm using a 1mm grid. I just need to go down 15mm and then across 10 and then back up, and there's my shape done. And now if I have a look on the 3D viewer just to make sure, and there we go, there's our little hole, the speaker. I'll just zoom in. Sorry, there we go. Bloody trackpad. There we go. So it's just, oh okay, I was just saying it's done, but it's not done. I still need to do this footprint, don't I? I've been putting it off till last. Alright, so I just need to group all this together, then I can rotate it. Group it, and then I can, was it positioning tools, move exactly. I want to do 45 degrees, there we go. And then, I don't know, I guess stick it there. What I'll do is I'll print out a full size, I should be able to print out A4. Yeah, I'll print out a full size and measure the speaker. So it does, so it will fit. That'll do. That'll do, Peg, that'll do. And then just a quick look on 3D viewer again. There we go. Looks a bit plain, doesn't it? I need to put some text on it. I wanted to try and put the UMPKR stylized text on as well. So I'm thinking maybe I have to take a photo of it and then modify it in a graphics program just to isolate the actual shape. But let me have a fiddle with this footprint first. So actually what we can do is make sure everything's going to work. Let's run Freerouting. Okay. Start now just to make sure everything connects up. Okay. Just look up here, make sure there's nothing loose. The only thing that's loose should be ground. Yeah, and then we can fill in the ground plane. What was it? Fill all zones. And there we go. We'll have a quick look at the 3D view again. Yeah, there we go. It might actually work. We might actually have some success with this. Okay. Let's try and figure out this header next. This connector. Okay, I've put it off long enough. Let's update the connector. So, like I said, so it's a DIN41612 connector, but the actual connector we've got is an SNP58 from Soviet, which uses 2.5mm, not 2.54mm. If I use 2.54mm, then I could just buy a brand new connector from anywhere. DIN41612 connector, but they don't. So what we need to do is open in footprint editor. So as you can see here, we're editing this from the board. Saving will update the board, but it won't update the the actual footprint. So first thing we want to do is we want to get rid of, so we've only got even pins, so we want to get rid of all the odd pins like so. And you can see so that there is space for these odd pins in the connector, but it's only the even pins that are actually there. So I'll go through and do all that. Okay, well, I won't take through all that. So the other important thing, I'm not too worried about the outline. The important thing is the location of the pins and the location of the mounting holes as well. They obviously have to match up so that we can slip it into the board. So if we have a look at the distance now, so between these two pins, you can see that it's 2.54, like I've been saying. And the distance down here will be twice that, so 5.08. So what we want to do is we want to change this distance to 2.5, and we want to change this distance to 5 millimeters. It's probably the quickest way to do it. Okay, well, the quickest way I'm thinking of doing it is that we can select all of the B row, blah 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 blah, and then what we do is we positioning tools, move exactly. So we want to get rid of that. So we want to move it backwards on the X axis by 0.04 of a millimeter, like so. Barely moved, as you can see. I'm going to have to redo this anyway, but you can see now it's 2.5 mil. That's what we want. Obviously I haven't done the whole row because I need to go and delete everything else, so I'm just showing you guys quickly. Now for this one here, same thing. So once we've moved all the B row, now we're going to have to do like the number 4 pins, number 6 pins, we're going to have to do them all separately. How am I going to do it? Yeah, okay, so we've moved them closer together. Now we need to move them closer together in the Y direction. So what we need to do is, so we can select both of those, and again, positioning tools, move exactly. And this time it's double, 0.08. We want to move Y, well hang on, which way are we moving? Yeah, we want to move upwards. So we're going to have to do positive, aren't we? No, wrong way. Okay. Let's try that again. So it is minus that way. There, okay, they're closer. So now if we check, we should now be 5 mils on the dot. 5 mils and 2.5 mils. And that's essentially it. But obviously you need to repeat it for all of these. And then again, yeah, I don't know, so I have to measure how far these mounting holes are from, say, that pin there or something like that, so that I can get it right. And that's essentially it, and then we can save it, and it should update the PCB, and then we can do a routing, and basically the board's ready to get fabbed and tested. So we're almost there. I think that is it. Just about done. So I've updated the footprint, and I've measured. So I've measured from this pin to the edge of the board. I've measured from this pin to the mounting pin. I've measured from the mounting pin to this mounting pin. So hopefully, I'm thinking maybe I shouldn't even have just get rid of these mounting holes, and then just drill them myself, but we'll see how we go. I've got the speaker cutout all done. I've added 2 mounting holes there, and I've measured them, so they seem to be 7 mil from the corner and then 5 mil up. So that's where I've put them. The only thing I haven't done is move all of this value text. So if you have a look at the value text, I can select it because I've grouped everything. I'll just select, because I've grouped all these key switches together. Can I select? Is that what I want to do? Oh, there we go. Alright, just properties. Everything's on the front fabrication layer, but if I want this text to show up so that when I'm building the board I know what keys go where, I need to move it to the front silk screen. It's probably going to be a bit tedious doing it for all of them, so I think what I can do is I think I can edit text and graphical properties, and I want to do, okay, on the front silk screen, oh no, sorry, on the fab layer, values, I think, and I want to change it to the front silk screen, I think. So that should be what I want to do. Apply and close. So now if I switch everything off, and I should have, I know I'm probably doing it the slow way. So what will be on the front silk screen is this. Basically, so I've got all my part numbers, part values, I've got all the key values there, so I know what the key switches are. 2K, okay, diodes, resistors. I think, what's that complaining about? It's complaining about something. Yeah, I think that should be good. Okay. I just want to show everything now, don't I? Anyway, so now let's run the auto router. Make sure everything connects up and I don't have anything that can't be routed. So tools, Freerouting. Okay, start. Oh, failed 0 is good. Right. I think everything, so it should just be ground that's not connected because I'm going to fill that in. So everything I think looks okay. Cool. Now let's fill in the ground on the bottom of the board. I think that's about it. Let's have a quick 3D view. So that's what it looks like. Of course I need to add some text and stuff like that. Add some text there. But yeah, otherwise it looks good. So now let's generate, so I've got all the Gerber files and everything I can now upload to my GitHub, and then if I want to upload it to PCBWAY directly, okay, there we go. So it's a more expensive board this time because it's a much bigger board, 200 by 320. But I'll do the cheapo shipping because it takes about 2 weeks and it saves a bit of money. It's $110, and I don't know, the board at the moment is yellow. I don't know if should I do yellow. I'm going to do a yellow board with black text. That's going to add some time. I'll add a bit of money as well, actually, as well. Yellow board. That's kind of what the colour is at the moment. Alright, I'll see if they'll let me do that. But basically, yeah, everything else I just leave as standard. Yeah, because they're a big board, so there's no point getting... If it was a small board, you can get 10 PCBs for the same price. But for this size, you're going to be paying extra. I don't need 10 boards. I only got one of them. So yeah, and that's it. And then away it goes. In 2 weeks' time, or 2.5 weeks' time, probably. We'll be able to try it out, build it and try it out. Hopefully by then I've fixed all the other problems up with the computer. So anyway, if you've stuck around this long, thanks for sticking around. Hopefully there's something of interest. If you've picked up anything I'm doing wrong or I could do better, I'm always eager to hear, so let me know. Okay, that's it. Bye for now.